Tell me what you know about experiments.
Testing an independent, dependent variable.
You're testing an independent and a dependent variable, okay? What else?
It allows you to have a control and then one so you can see what's influencing it or not.
Yeah, you have a control group and an experiment group to see what is causing the change or what influence there is. Okay. What else? What's the advantage of the experiment versus a content analysis or a survey? What's to do?
Designs? No.
See what you're doing in action.
See what you're doing in action? Maybe a little bit. You're meaning like if I do my survey, I don't get to see them work on the survey?
Well, I mean, like if you're proposing a hypothesis, you can see it like actually in action as opposed to like, it's just a completely different method than the survey.
I think I understand what you're saying. Yeah, if you do an experiment, you're going to be more actively involved. Where are we going here? Uh-oh. Now you got a sneak peek. You don't want that. There we go. What's wrong with your thing here, Savannah?
It's crazy.
If you're doing an experiment, you're going to be more actively involved immediately in the data collection and thing. Because if you do a survey, you're sending your survey out. They may be collecting it or maybe completing that survey on their own. If you're doing a content analysis, they've already written the text, they've already taken the pictures, they've already done the broadcast, and you're getting it after the fact. So I agree with you there. Other than the fact with the survey, sometimes you're doing it face to face. Okay. What is it that you can get from an experiment that you can't get from those other methods? In surveys and content analysis, oftentimes we're looking for what? I drew the chart for you. You got the y-axis and the x-axis, and you've got the line going this way or that way. What are we looking at there? Starts with a core and ends with elation.
Correlation.
There you go. You're looking for a correlation. Okay.
Thank you.
You want to see if there's a correlation between one thing and another. What does an experiment let you find out?
What that actual relationship is?
Step further than that. Causality. With an experiment, you're going to be able to find some causality. Okay, so that's what we're going to talk about. That's the advantage of an experiment versus the others, and we'll find out how we go back into that. Okay. The experiment is the most controlled of all the other methods. Why is that?
Because you're able to have that control group and then the one that you change or something.
Yeah, you have a control group. You can determine what group is going to be in, which people are going to be in which group, and what we're going to do with them. Okay. Yes, you can control a survey to an extent because you write the questions and you make the design, but you just have to get the data that comes in that's already there. Same thing with the content analysis. You can operationalize the definitions and lay it out, but you don't really have any control other than that. You don't have any control of what kind of advertisement they put in that magazine or what photograph they have in that advertisement or what the announcer says on the newscast. Okay? You actually control everything in the experiment. Again, it provides for more than just correlation, it gives you causality. You can find out why things happen, the cause and effect. So the correlation, we're looking at the relationship. With causality, we're trying to make that prediction. This is what's going to happen. For example, if I'm doing a study on ice cream, and I want to look and determine if ice cream causes weight gain. If I do a survey, I'm going to ask questions like what?
How often and how much?
How often you eat ice cream, how much ice cream you eat, do you put toppings on it, what kind of ice cream you eat, do you go for 1 scoop or 2, okay? And I may ask you, looking back last year, roughly how much did you weigh? And how much do you weigh now? Okay? And we may find that everybody who eats an X amount of ice cream has gained 5 to 10 pounds in the last year. So we see there's a correlation. The more ice cream they eat, the heavier they are. Okay? So we can tend to look at that and say, well, yeah, ice cream's causing them to gain weight. There may be a correlation there. But what's the flip side of that?
There may not be.
There may not be. Why not?
Because, I mean, other things affect your weight, like perhaps you were like super into exercising and then you stopped, or you eat other things, or health issues, or et cetera, et cetera.
Yeah, you may have had health issues, and so you had to start exercising more, or you may have gotten injured and had to start exercising less. You may have started exercising more and you gained weight because muscle weighs more than fat. You may have gotten healthier, but weigh more, okay? You may have started eating more ice cream, but you started eating more of everything, okay? What about with an experiment? Well, with an experiment, I can do a longitudinal study, which means it takes place over time, and I can randomly select two groups, and one's my experimental group and one's my control group. And one group I'm going to give the ice cream to. And I'm going to say, you need to eat X amount of ice cream, X number of times a day, X number of times a week, for this length of time. And then when we get, and don't change anything else, don't start exercising more, don't start eating more salads, don't do anything else different than what you're doing now, okay? Same thing with my other group, except they're not going to start eating the ice cream. And then at the end of that time, I'm going to look and see, is there weight gain? And that's going to be able to tell me, it looks like the only difference we have here is this group ate more ice cream than that group, weight gain. That would be a bad experiment to find out that ice cream's that bad for you, okay? Your basic concept is you have two groups that are randomly assigned. You're going to take this one group, and it can be a convenient sample to get that one group, but you're randomly going to assign them into the other two groups, okay? You're going to expose one group to the experimental design, which is your X, and one group to the control design. That's your C. You're going to want to measure your dependent variable. So for instance, in my research group 1, I've got my experimental design. I'm going to look at the dependent variable for that group. And then I've got my control group, and I'm going to look at the dependent variable for that group. And this is what I'm trying to compare. So I find out, did my dependent variable have an influence, have an impact? We're looking to find if that dependent variable, or that independent variable, or our predictive variable has a cause. If that causes something to happen with our dependent or our measurement variable. And again, you can control this because you're taking one group and you're taking the stimulus away from them. And then you've got your other group and they're getting the stimulus, okay? For example, topics covered in the news media will influence what viewers believe are important topics. Topics covered in the news media will influence what viewers believe are important topics. Okay, what's the independent variable there? What's the cause?
The topics,
Topics. Okay, what's the dependent variable?
the viewers believe.
Viewers' beliefs, okay? If we cover, let's say right now we cover ISIS a whole lot. Are they going to believe that international issues are most important? What about if we cover sports more? Are they still going to believe that international issues are very important? That's going to give us we're going to be able to tell, because is it the way we cover it, what they think is more important? Or is it just they already have their own opinions? So if we're covering it and they think it's important, we're doing a good job. If we're not covering it and they still think that another topic's important, then we're not giving them what they want. Does that make sense? Okay, so our system, like anything else, you're going to develop your research questions or your hypothesis. You're going to select the appropriate experimental design, which we'll talk about here in just a minute. You want to operationalize your variables, manipulate the independent variable. You're going to randomly assign your participants, conduct a pilot study. Why do you do that?
See how well your experiment actually works and if you're collecting the data you need.
Say that again, I'm sorry, Mary Kate.
To see how well the experiment actually works and if you're collecting the data that you need and if there are any issues.
Yeah, see if it works, see if it's cumbersome, see if the participants, if it makes sense to them. If it doesn't make sense, that in itself is going to mess up your study, okay? Then you're going to administer the experiment, you're going to analyze and interpret your results, and then you're going to present your data analysis. Basically the same as with any other system. Okay. Your research question or your hypothesis should include both the independent and the dependent variables that you're considering. Does gender of manager influence the perception of manager's emotional stability? Does the gender of the manager, that's my independent variable, influence perception of manager's emotional stability? That stability should be underlined too. So I've got my male or my female, and I'm looking at their emotional stability. Independent variable is the gender. There's 2 levels. The dependent variable is emotional stability. And that's what I want to determine. Another example. Comedy programming increases positive mood more than dramatic programming. So the programming is going to have an influence on the positive mood, or on mood. Okay? You have your independent variable and your dependent variable in your research questions or your hypotheses. Okay, there are many types of designs. The post-test only, you've got your 2 random groups. You've got your experiment group and your control group, and then you look at your observation 1, your observation 2. Okay? So I'm going to give this group the ice cream. This group, no ice cream for you. And then I'm going to weigh you. Versus the pre-test, post-test. I'm going to weigh them. I've got my 2 groups, so I'm going to weigh each group that way. Experiment, control, and then I'm going to observe, see if there's a difference. Here, what would this tell me off of the ice cream experiment, or ice cream example we gave? Not a whole lot. I'm trying to determine if ice cream causes weight gain. Well, I don't know what they weigh to begin with. I may find that this group's heavier. Well, that's not really going to tell me anything. They may have been heavier to begin with. Okay? This one will tell me if there's weight gain. So why would you do the post-test only? If the before doesn't matter as much. An example or experiment that I would like to try doing is I teach a public speaking course that's predominantly online. We meet the first day and then we only meet to do their speeches. I give them the chapters that they're supposed to read. I do a PowerPoint presentation that they're supposed to view. They have an assignment they do off of each chapter. They have an assessment they do off of each chapter. I have example videos that they're supposed to watch for those speeches, and then they give their speeches. Versus when I teach face-to-face, I try and do more in-class activities that you don't get assignments off of each chapter. You don't do an assessment off of each chapter. You get a midterm and a final, and then you give your speeches, and we're together more. Well, my control group could be the ones that are going to take the class online. I'm sorry, my experiment group could be the ones that are going to take the class online. My control group is going to be the one that are going to be face-to-face. So I'd get a face-to-face class, and I would randomly select, and I'd say, you, not you, you, not you, you, not you, you. The yous are going to go take this class online. The not yous are going to take the class face-to-face. And then I want to see if there's a difference in their grades at the end of the semester. If they're one group's performance is better than the others. Okay. To find out, is the online approach where they have to do a lot of the work on their own, they have to go in and they take the assessments, they have to do the assignments, so it really gets steeped into their brains. They get to watch the examples. If that helps them understand how to give these speeches, and because they only have to do it 4 times to get in front of the class 4 times, they can power through any kind of nerves they have, if that's more effective. Or if it's the group that's together all the time, and they're getting to know one another a little bit better, and we're face-to-face more, if they're more comfortable, and therefore they get it more, and they get the better speeches. Okay? Really though, the time you only use the post-test is when you have a short time between the pre and post-test, and it's really not going to make that much difference. If I've only got about a month, well, you're not going to gain a whole lot of weight, by eating ice cream that amount of time. Okay? Because you do the randomization, it's typically okay to use that post-test only without the pre-test, because you're randomizing the groups anyway. Okay. When you use the pre and post-test in an educational setting, because typically what? You have the whole semester to work on it, so you have longer time. Or if you're in high school, you have a whole year possibly you could be working There's a long time between that pre and post test, so you can really tell, is there gonna be a big difference? Okay. I tried this in my reporting class. When my students first came in, Andy, I don't remember if I did this in your reporting. Did you have reporting with me or did you have it with Dr. Fair?
I think Dr. Fair.
Okay, then you wouldn't have done this with me. In my reporting class, I had them do a pre-test where I asked them a bunch of grammar questions and a bunch of AP style questions. And I looked at,
Advanced?
Hmm?
Was that advanced?
No, that was my intro. And I looked at their grades and saw what their scores were. And then we went through the semester, and of course, we talked about grammar, we talked about AP style, they wrote all their stories, I graded them on all those things. The idea being, by the end of the semester, they had to do much better on those tests. So I gave them the test again at the end of the semester. All right? Now, what would be the problem if I did that when I had a very short time between?
Chances of them retaining what you're teaching them is a lot less likely.
Is what?
Less likely.
It's less likely, because for one thing, I haven't taught them everything yet. I haven't gotten a chance to go through everything yet. But on the flip side of that, especially if I give them the test back, they're going to remember those questions. And they're going to remember, oh, I got that one wrong, and that one wrong. It must be the opposite. There's only a couple ways that I got a 50-50 chance of getting this right in the first place. And I remember I got it wrong last time. Whereas if we go the whole semester, they're not going to remember what they got right and what they got wrong. Okay? But I also have more time in that semester to teach them and get them this information. So hopefully by the time they do this one, it's a markedly better score. And thank goodness it was a markedly better score for about everybody. Okay? Like I said, you're going to use a convenience sample, but you're going to randomly award. Why is that okay to do? Just use a convenience sample and then randomly assign.
You're still being random.
You're still being random within that group. Okay? And I still am going to talk about, I wouldn't do like the ice cream example. I wouldn't say Americans if I was using, say for instance I used a film appreciation class. Typically we have about 100 in that class. I wouldn't say Americans because it's just one subgroup on a campus. All right? Also, why else is it okay to use that convenience sample? Are you going to have 2,000, 3,000, 4,000 people involved in this experiment? Probably not. You're going to have a smaller group. So generalization to a much larger population is going to be difficult anyway. Okay. So use a convenience sample, but then randomize within that. Now you can do several of these. So I could do this ice cream thing with college students. I could do it with some high school students. I could do it with seniors, people in their 50s, 60s, 70s. And then look at the differences between those groups, okay? If I've got 4 conditions, I'm going to have 120 participants, 30 per condition, and then I can go to one of these random number generators, and it's going to randomly select those people. So I'm going to number all 120 participants, and then bam. It's going to tell me participant number 1 is a 4, participant number 2 is a 3, participant number 3 is a 2, and I'm going to put them into their groups that way. And that's what it does. It's going to take away the similarities and the differences because, you know, I'm a very, very different person than Kira. I'm much older, I'm male, you know, this goes on and on and on, okay? So we're very different. Well, it's going to wash that out because there's probably going to be somebody more like me in the group, and we'll take care of that, okay? And again, you need fewer participants for an experiment. Next, we're going to talk about operationalizing the variables, the manipulation of the independent and the operationalization of the dependent variable. You're going to take that abstract idea and you're going to turn it into a reality, okay? And that's the beauty of the quantitative method is you're in charge of this. You get to determine what does that mean. So, for instance, if in the ice cream example, if we wanted to say it causes obesity, well, what do we mean by obesity? At what point are we obese? There's so many different scales you can look at. Hypothesis is individuals will appreciate a birthday card sent via postal mail more than getting an e-birthday card or text message. The independent variable is the type of birthday greeting at 3 levels, the postal mail, the email, or the text. The dependent variable is your level of appreciation. Well, what does this mean? How do we measure a level of appreciation? Well, that's what you get to operationalize. Okay, that's what you get to determine. You also get to operationalize independent variable. Type of birthday greeting. Well, what do we mean by type of, how come telephone call isn't in here? How come text message isn't there? How come Twitter announcement or Facebook posted? We get to determine it, okay? So that's part of your job as a researcher. Individuals will appreciate a birthday card sent via postal mail more than getting an e-birthday card or text message. Your independent variable, again, is the type of birthday greeting on those 3 levels. So you look at the postal mail, the email, the text, and you're measuring that level of appreciation. To do this, you're going to write out some scenario paragraphs, such as, imagine it's your birthday and you go outside to open your mailbox and find a birthday card from your friend. So I've given you a scenario. Or imagine it's your birthday and you go to your computer, open your email, and find an e-birthday card from your friend. Same thing with text messages, you go to your phone. And then this scale will be used with all 3 of those. So I give scenario 1 with the, what was the first one? That was the postal mail, right? And I'm asking these questions. My friend is thoughtful, appreciate my friend's actions, it makes me feel good to have a friend like this. And then we have our scale. Again, in experiments, quite often, we use a survey because that's how we're going to get our data to measure it. So what we're going to do, say it was just these 3 questions, we're going to add all 3 scores and divide by 3 to get an average or mean score. So if they write a 6, I appreciate my friend's actions. My friend is thoughtful, yes, they acknowledge my birthday, so they get a 6. I appreciate my friend's actions, no, not really. I would have preferred, they come see me, 4. Makes me feel good to have friends like this. Yeah, at least they recognize my birthday of 5. So that's what, 9, 6, 15, my average mean score, or average or mean score is a 5. Okay? And you're doing that for all 3 of these. Okay? Questions so far? I'm kind of rolling through this, and y'all are sitting kind of quietly and glazed. Not those of you in online land, I don't know what you're looking like. You got to play to the camera. Are we good? Is making sense? That scenario we were talking about there, go back one. So when we're looking at something like this, are you going to have one group that gets the postal mail, one group gets the email, one group gets the text? You're probably going to give this to your control group and your experimental group, okay? But they may be made up of different bodies, maybe made up of different groups. Or you could have 3 different groups here. You could do it that way. Have 3 different groups, and one group gets the postal, one group gets the question about the email, one group gets the question about the text. Because what's going to happen if you have, say Savannah has to answer all these questions, well, I guess of all of you. If you're answering all these questions, what's going to happen?
If you prefer one or the other, it's going to bias your scores.
Yeah. If I'm doing this by myself, so actually I screwed that up, you would give one group the postal, one group the email, one group the text. Because we're just doing this, everybody's getting it, that's just a survey, okay? And like Andy said, well, if I like the postal mail, then I'm just gonna be thinking in my head, what did I say to postal? I don't like the email, so I need to make sure those numbers are lower. I really don't like the text, so I gotta make sure those are lower. So you're gonna bias it yourself. But if you're thinking just on the postal, just on the email, just on the text, then you can compare those 3 groups to see which one they prefer. Okay? Okay, again, your pilot study is used to check to see if the independent variable and the dependent variable are doing their jobs. That's your test. You're just trying this out to see if it worked. You can do a manipulation check, see if the independent manipulation is recognized. That's going to come at the end of that measurement or the observation. So you're going to see, did they figure out what the independent variable is, and did you recognize that? Okay. What type of birthday wish did your friend send you? Well, they sent me a postal mail card. Okay, you figured that out. Okay. And then you can also do some reliability analysis because dependent variable, if multiple items are being used as a scale, do they hold together? You want to measure all that, and you do this in SPSS to see those 3 questions we asked, are they all related to appreciation? Do they hold together as one concept of appreciation? And what you're going to be looking for is your Chrome box alpha. So So you'll do a reliability test on SPSS. If your Chromebox Alpha is 0.80 or higher, they're holding together and it's reliable. Okay? But you don't want to do this in your experiment, why not? When you actually do your experiment, you don't want to test for the reliability. How come? Don't overthink it.
Because it should already been done.
Well, yeah, but why? If I do my experiment and then I check my reliability and my Chromebox Alpha comes back at 0.62, I just did this experiment for nothing because it's not reliable. There's no point in using it. Okay? You do the pilot test to check the reliability. Think your content analysis. Do you check your intercoder reliability after you've done the content analysis? No. You do that in your coder training. Same thing here. You do the pilot test to check it and make sure it's reliable before you actually go out and do it. Same with the survey. You can, these are the different types of statistics, the descriptive statistics or the inferential that you can be looking at to make comparisons. You can notice with an experiment, see if there is a correlation. You still can check that. But because you've got the experimental group and the control group, you have a better chance of determining causality. Do you see the value in doing an experiment? Okay, now that we've talked about all three, content analysis, survey, experiment, which one do you think is the most difficult?
Content analysis.
Content analysis, how come?
Because there's just so much information to pour through. And like making sure that you have clear definitions and making sure all of your coders understand.
Two people coding, you have to have a second coder, so that's like,
Avoiding subjectivity.
The thing though about having two coders is, say you're going to look at 2,000 units of analysis, well you only have to look at 1,000 versus the other person looking at 1,000. If I do a survey and I get 2,000 responses, I have to input all 2,000 of those things. I guess I suppose I could have somebody put in 1,000 of them and then just combine them, but that's kind of a pain. You said the subjectivity, and that's, you know, that's the thing with any kind of research you got to keep in mind is you as a researcher. Turn this off. Jumping around all week.
Speed viewing.
I'm speed viewing. Yeah, are you speed reading? You keeping up? Are you keeping up? The thing with being a researcher is any type of research methodology you use, because you're the one doing it. Thank you, Stan. Because you're the one doing the research, you get to operationalize your terms. You get to determine what parts you're going to include in this study. You know, we looked at with the birthday greetings. They got to determine, you know, gosh, I could look at text messaging, I could look at emails, I could look at snail mail cards, but then I could also look at phone calls. I could also look at sending flowers or balloons. There's so much you could cover. You get to determine what that is. And then when you look at level of appreciation, well, how many questions am I going to ask to determine their level of appreciation? So you get to determine those things. With the content analysis, oftentimes you get to define the terms. But what is the critical piece to doing that? To operationalizing your terms in any kind of study you do? What is the critical thing that you must do and do well to lead you to those definitions? It's not your introduction.
lit review.
Lit review! I'm going to take it. You have got to do a solid lit review. You have to make sure that you're looking at the most relevant articles, that they're current, that they are related to what you're studying, and even if they are a little bit different, that you acknowledge how they're different and what they did that you haven't done. Okay? That's going to guide you to having solid research questions or hypotheses and good definitions. And then in coder training, it's just a matter of getting somebody that works well with you, that you can go through this and explain to them, and you can brainstorm on what are we going to include in this to do our study. Okay. Same thing with an experiment. You have to determine what is my dependent variable, what is my independent variable, why am I looking just at that? Is there anything I'm going to leave out? And then take those groups. And the other big important piece in doing quantitative research, make sure your population is solid that you have enough of that population so that your margin of error is reduced, and that you randomly select, because that's when you can generalize. If you're gonna do a study and say, I really don't care about generalization, then do a qualitative study. Okay? Because in qualitative, there, yes, you can do some generalization there, it's just on a smaller scale. Okay?